let's use the unit circle to find sine and cos of certain angles. Okay, so first we have to find out what this angle is and where it's located on the unit circle. So you want to, if you're like me, you'll want to convert this angle from radians to degrees in order to plot it on the unit circle. So what I'll do is I take pi equals 180 degrees. And then 5 pi over 6 is 5 times 180 degrees over 6. 180 over 6 is 30, and 5 times 30 is 150. So you are going to draw the angle of 150 degrees on the unit circle. That's 30 degrees short of 180, so here is my plot. So this is 30 degrees and here is 150 degrees. So my point is here. So this is P of 5 pi over 6. And I see that it's a mirror image of one of the fundamental points in the first quadrant. It's mirror image of 5 pi over 6, which is the mirror image in the 45-degree line of P of pi over 3, which I remember because it's the 60-30 triangle, so it's like this. Okay, so for this one I have coordinates 1/2 and square root of 3 over 2. For this one I have to switch x and y, so square root of 3 over 2 comma 1/2. So this one is mirror image of that, and the x coordinate is square root of 3 over 2 with a minus sign, and y coordinate is not changed, so that's 1/2. The first coordinate is cos, the second coordinate is sine. That's always the case. So because I want to compute what is sine of 5 pi over 6, I will take this as my answer. So my answer here is 1/2. Okay, next one, cos of 4 pi over 3. So I have to compute what is 4 pi over 3 in degrees. I'll replace pi with the 180, so I have 4 times 180 over 3. 4 times 60 is 240 degrees. 240 degrees is 60 degrees past 180. So this angle here, this angle is 240 degrees. And therefore this point is point corresponding to 4 pi over 3. Now that's an exact mirror image of the point we started with, P of pi over 3. It's mirrored in the origin, so both of its coordinates are negative. So negative 1/2 and negative square root of 3 over 2. Now we're looking for cos. Cos is always the first coordinate, so I just read off what this is. Cos of 4 pi over 3 is negative 1/2. Okay, next example is so you have to find sine of an angle that's that's not between 0 and 360 degrees. It's much more than 360 degrees. If you convert it, you can use your calculator to find what this actually is, and it's gonna be something big. So what you do here is you use the fundamental property of sines, that any angle of 2 pi, if you add 2 pi, you've made a full circle and you've come again. So this is really sine of 28 pi over 3. So let me rewrite 28 pi over 3 in a different way. I'll take this 28 and I'll write it as 27 plus 1 over 3 pi. So then I'll have, this is sine of 27 over 3 is 9. So 9 pi plus 1 over 3 pi. Okay, so this is sine of 8 pi plus pi, that makes 9 pi, and plus this leftover angle, which is 1/3 of a pi. But because 8 pi is a multiple of 2 pi, this would be the same as sine of pi plus 1/3 pi. So this is sine of 4/3 pi, and this is an angle on the unit circle. In fact, we already found it in the previous computation of cos of 4 pi over 3. We also found the other coordinate, which is the sine. So I just read it off. Sine of 4 pi over 3 is negative square root of 3 over 2. Okay, so for the last problem, we have to remember what tangent is. How is tangent defined? Tangent is sine over cos. So you'll have sine of 11 pi over 3 divided by cos 11 pi over 3. So we have to find where is 11 pi over 3. So the same thing. So 11 pi over 3 is, I'll take a nearest multiple of 3 to 11. So that's 9. So I'll split this 11 as 9 plus 2 over 3 pi. And that's going to be 9 over 3 is 3 pi plus the leftover 2/3 pi. So then I'm gonna have that tan of 11 pi over 3 is equal to tan of 3 pi plus 2/3 pi, but tan has period of pi instead of 2 pi, like for sine and cos. Tan has period pi, so tan of pi is the same as tan of 2 pi, and etc, etc. So tan of 3 pi disappears here. We get, by periodicity, we get the same answer as tan of 2/3 pi. Now we need to see where is 2/3 pi on the unit circle. 2/3 pi is the mirror image of pi over 3. So this is p of 2 pi over 3. It's mirror image of p of pi over 3, so its x coordinate gets a negative sign, the y coordinate stays the same, and the first one is cos, the second one is sine. So I get that tangent is sine of 2/3 pi over cos of 2/3 pi. And then I just read off what these numbers are. Sine is square root of 3 over 2, and cos is negative 1 over 2. And when I cancel out the double fraction, I get exactly negative square root of 3. And that's my final answer.